During this session, we're going to look at 6 different types of graphs that we can construct when we're dealing with a data set. Let's look at our first objective. Learn how to graph and interpret quantitative data sets using stem and leaf plots and dot plots. Here's our first example. Use a stem and leaf plot to display the data. The data represent the scores of a biology class on a midterm exam. So we notice that we have quite a few values. Our smallest value looks like it's 67, which is here, and our largest value is in the 90s, and that value is the value of 95, which is our maximum value. We'll have the same information here, just give us a little bit more room. To construct a stem and leaf plot, what we're going to do is to separate this into 2 digits, thinking of the 75 as being a 7 as my stem and the 5 as a leaf. And we're going to notice that because our smallest value was in the 60s, we're going to start off with the stem of 6, and then we'll have 7, 8, and our largest value was in the 90s, so we'll have a stem of 9. We're then going to draw a line next to each of these stems, and we're going to start putting on the leaves. Now, one thing that's going to be important as we're adding numbers here is to make sure that we continue to keep them in columns, and we also want to indicate what the key to this is. So for instance, our first entry is going to be a 67. We're going to explain that 6 with a line and then 7 is equal to the value of 67. In the 60s, we have 2 values. We have the 67 and we have the 68. We want to list them in order, so we're going to put our 7, and then we're going to move over and put the value of 8. And we've taken care of all of our 60s. Now let's go ahead, and I'm going to keep track of the fact that I've already dealt with those. Let's underline all of the ones with 70s. So we have the 75 in the first row, we have a 73, second row, we have another 75, a 79, and a 76. And so if we look through this set, we notice that the smallest of those 5 is the value of 73. We're going to go ahead and put the 3 down first. And now let's continue by getting our next value. We have 275, so we're going to list a 5 and then another 5. And once more, make sure we're keeping these in columns because you'll see why in a moment. Then we're going to use the 76 by putting the 6 down, and then a 79. So again, I'm really concerned about the spacing here and making sure we keep things in columns, and also that we want the same space between the columns. Now let's look at our 80s. We, in our first row, have the 85, the 80, we have an 87, 82, 88. We have in our second row the 80, the 83. Third row we have the 87 and the 85. Well, notice that we have the value of 80. We have 2 of those. So we're going to use 2 zeros to indicate that as our leaves. The next value that we come up with is the value of 82. And so we only have 1 of those. Let's go ahead and put down the value of 2. Again, column, make sure you keep it in line. We have the value of 83, and there's only 1 of those. Then we have an 85 in our first row, and we also have an 85 as our last entry, so there are 2 85s. Let's transfer those over. We have an 87 in the first row, and notice we also have an 87 in the third row, 2 87s. And we also notice we have 1 more underlined value, that's our 88 in our first row. Now, everything that we have left are in the 90s. We have a value of exactly 90, so I'm going to put down a 0 next to it. We have 3 values of 91, so we'll list our 1s. We have a value of 92. We have a value of 94. And then we have 2 values of 95. So what we've done is to construct our stem and leaf plot in this manner. Now, the reason for making sure of our spacing is that we can now look at the stem and leaf plot and kind of think about it looking from the side. We can see which values we end up with the most. It appears that the most grades for the biology midterm were in the 80s or in the 90s, and you can actually see that there are more 80s than there were 90s, and notice that there are not too many 60s, which is probably a good thing. Now let's look at our second type of graph called a dot plot. Use a dot plot to display the data. The data represent the systolic blood pressures in millimeters of mercury of 30 patients at a doctor's office. And so we have quite a few numbers illustrated here. Again, we're going to give ourselves some space, and to work with the dot plot, we're going to have a horizontal line, a horizontal number line we're going to draw. Notice that all of the values are in the hundreds. So let's just go ahead and draw our horizontal line. And we're going to start with the value of 100, and then let's just move up by tens. So we're going to have 100, then this will be 110, we'll have 120, 130, 140, 150, 160, 170, 180, 190, and then 200. Now, to work with a dot plot, what we're going to do is first give it a title. Let's just call this systolic blood pressure. And we're going to run through our values, and as we're doing so, we're going to put a dot above each of the entries as we have the numerical value represented. So 120, for instance, will be a dot right above the 120. A 130 will be a dot right above 130. Another 120 will move upward. Again, we're going to be interested in keeping this so that we end up having the same thing going across, as in when I get to a second entry, I want to make sure I put it in line with this one. Let's go to the next entry, which is 135. So we keep it at the same level as the first. 110, 130, we have 140, 160, another 140, 145, 180, 170, 130, 200, 120, 150, another 150, 165, 120, 200, 150, 170, 135, 130, 145, 140, 135, 125, 120, and finally 140. Now, what we can say is that this is going to be given, this is our systolic blood pressure again. And one thing you can do is, if you're listing this on the horizontal, is go ahead and put your units. And this is going to be in millimeters of mercury, which can be abbreviated Hg. It appears then, by looking at what we've got with our dot plot, the systolic blood pressure tends to be between 120 and 150 millimeters of mercury. Of course, you can also make other interpretations. You can say that in this group that it's very odd to have a value that's above 170. You can also say that this is kind of odd also. You only had one person that had a systolic blood pressure below 120, but maybe that's not too far off the mark. But again, you can really see by the dot plot what's going on in general. Now let's continue on by looking at our next objective. Learn how to graph and interpret data sets using pie charts and Pareto charts. Use a pie chart to illustrate the data. The data represent the 2010 NASA budget request in millions of dollars divided among 5 categories. We have science, aeronautics, exploration, space operations, education, cross-agency support, and inspector general, and the values in millions of dollars associated with each. Well, I've transferred that data over to the next screen, and I want to work below it in order to come up with a pie chart. Now, to work with a pie chart, we really need to know how many degrees in a circle we need to come up with in order to represent each of these different 5 values. To do so, we're going to need to know what the total is. So if we add these 5 together, we come up with a total of 18,686. We're going to take each of these entries and we're going to write it as a percentage of this. So if we look at the percent of the budget that's being represented, for 8,947 divided by our total of 18,686, we come up with a value of 0.479. We can do the same thing for each of our entries. So I've gone ahead and done this previously, but you can see what we're doing in order to get this. This is about 33%. We've got less than 1% represented by education. We end up with about 18% represented by cross-agency support, and another less than 1%, in fact, this is only 0.2% for inspector general. We want to take these values and come up with the degree measure that's going to be necessary on our circle. Well, we can take each of these and multiply times the number of degrees in a circle. That is 360 degrees. So if we take a calculator and multiply 0.479 times 360, we end up with a value that can be approximated as 172 degrees. Now that should make sense to you. If this is close to half, a little bit less, in a circle we have 360 degrees, half of that would be 180, and so you can see that this is going to be represented by close to half of the complete circle. We can do the same thing with each of these entries, and I've done that previously. We have 119 degrees represented here. We end up with 2.5 degrees for the third value of education, and then we have 65.5 degrees, and then we end up with 0.7 degrees. Now that we've come up with the degree measures that we would need, we're going to now draw a circle. Go ahead and get a new sheet of paper for this, and I'm going to use a protractor. And I'm going to draw a circle. Of course, you could use a compass to do the same thing. This isn't going to be exactly accurate, but it's going to be close enough for you to get the idea of how to work with it. Our center of our circle is approximately right here. Now, we're going to take the value that we came up with for the science, aeronautics, and exploration. We said we needed 172 degrees to represent that group. And we're going to go ahead and start with a vertical line or a radius drawn upward. And I now want to measure off 172 degrees. So using my protractor, I can start off with 0 here and work my way around. And 172 degrees is right here. Make a little mark. And I'm going to connect from the center outward. And this sector of the circle is going to represent the 47.9% of the budget that ends up being for science, aeronautics, and exploration. Now, one way to work with a pie chart is to now go in the other direction. You can choose what you want to put next to it. Let's just go ahead and look at space operations. We have 119 degrees that we need to work with for space operations. This time I think what I'm going to do is go 119 degrees clockwise. So 119 degrees is going to get us to about right here. And again, extending the radius. we're going to have the 33% represented here for space operations. Looking back at our values, we need to have our next biggest group is here with our cross-agency support. We need about 66 degrees to work with that. So I'm going to go ahead and put that coming off of this line, this radius. Let me go 66 degrees. Now notice that I'm not going to have much left over, but then there isn't much left over. So 66 degrees is about right here. It's going to be very hard to illustrate the other two sections because they're going to be so tiny. And this is going to represent the 18.2%, which is going to be our cross-agency support. And now this little section needs to really be the other two put together, and it's not much difference because one of them is about 0.7% and the other one's about 0.2%. So I'm going to divide it up just barely here. And I'm going to have to use arrows to indicate what's going on here. So this section is the larger one. That's going to be for education. That's 0.7%. And then the smaller section, the one that's right next to it, this is going to be for our Inspector General. And that's the 0.2%. And we end up then representing, using this pie chart, our 2010 NASA budget. And of course, what you can look, when you look at the pie chart, it's pretty easy to see that most of NASA's budget was spent on the science, aeronautics, and exploration. So it's a nice visual to represent this. Now, another way we can graph qualitative data is by using something called a Pareto chart. Let's look at that next. Use a Pareto chart to display the data. The data represent the ultraviolet indices for 5 cities at noon on a recent day. So we have Atlanta, Georgia at 9, Boise, Idaho at 7, Concord, New Hampshire at 8, Denver, Colorado at 7, Miami, Florida at 10. So again, giving ourselves a little bit of space, we want to work with a Pareto chart. Now, a Pareto chart is a vertical bar graph, and the height of each bar is going to represent the frequency or the relative frequency. So we're going to start off with our horizontal axis. And on our horizontal, we're going to want to put our cities. And then on our vertical axis, we're going to be working with the values that were given here, dealing with the ultraviolet indices for these 5 cities at noon. Now, we also want to make sure that we start with the bar that represents the largest value, and we're going to start with it to the left. So the value that we're going to begin with is the one for Miami, Florida. So we're going to put our city for Miami, Florida first. And we're going to draw a bar above it, and we want to go all the way up to the value of 10. So I'm going to move by 2's on my vertical axis. And this would be our UV index. And I'm going to draw a bar from Miami going upward to the value of 10. Now, this is not a histogram, it's a bar graph. And so the difference is that we're not going to connect the bars to each other. This isn't a numerical value along the horizontal. Instead, it's qualitative data. And so we're now just going to pick up the city that had the next largest UV index, and that's Atlanta, Georgia, with a value of 9. I'm going to go ahead and just move over and put Atlanta. I'm going to go up to a value of 9. One thing you do want to do is try to make the bars the same width so that it's not deceptive in any way. And then go ahead and pick up the value at Concord of 8. So let's move over, label Concord. Go up to the value of 8. Put a bar. And then for Boise and for Denver, we both have the value of 7. Doesn't really matter the order. I'll just probably do it in alphabetical. So I'm going to put Boise first and go up to 7. And then we'll have Denver last. And that bar will be the same height. And so what it appears is that Boise, Idaho, and Denver have the same UV index. And of course, you could also say it looks like Miami had the largest from the chart. Now let's look at our final objective. Learn how to graph and interpret data sets using scatter plots and time series charts. Here's an example. The lengths of employment and the salaries of 10 employees are listed in the table. Graph the data using a scatter plot. So along the first column, we notice the length of employment in years, and along the second, the salary in dollars. Well, we have the same information on this sheet of paper. That leaves us some space in order to work with. What we're going to do is on our horizontal axis, we're going to go ahead and use the values for length of employment. So this will be length of employment and of course what we're working with here is in years. And we notice that we have a value of 10 as our largest. So I'm just going to move up by 2s. So 2, 4, 6, 8, and 10. On our vertical axis, I'm going to put the salary in dollars. Now, the smallest value, our minimum is at $25,000. They're all under $50,000. So I'm going to go ahead and put a little mark indicating that we're not going to start at 0. And moving upward, these will be our salaries. And I'm going to put this in thousands. I'll start with the 25,000, so I'm going to put a 25 here, and then move up by 5. So 30, 35, 40, 45, and then 50. And now, for each of the entries, I'm going to have an ordered pair. We'll have the value 5 and 32,000, and so we'll go over to the value of 5 and go up to 32. So I'm going to kind of get a little in line here. This will be about right there, and put a dot. The value of 4 and 32,500. So at 4, we have 32,500, which is going to be just a little bit higher. We have the value of 8 and 40,000. So we'll go over to 8 and to the 40,000. Have it. I'm working with the upper right corner, as you can see. Then we have the value of 4 and 27,350. So at 4, we have a value of 27,350, which is just below this one. Then we have 2, 25,000. So 2, 25,000 is this dot. We have 10, 43,000. So at 10, I need to go over to 43,000. Let's see, I'm going to use it this way. And about right there. We have 7 and 41,650. So at 7, I need to go up to a little above 41,000. About right here. At 6, we have 39,225. So at 6, we're going to be just under 40,000. About right there. 9, 45,100. So at 9, I need to go to just above the 45,000. And at 3, I have 28,000, so 3 and 28,000, about right there. And we now have a scatter plot which is telling us a little bit about the salaries related to the length of employment. And of course, what you can see is, by all indications, the longer you're employed, the higher your salary ends up being. Now we're going to look at another type of graph called a time series plot, which is similar to the scatter plot. Use a time series chart to display the data. The data represent the daily high temperatures for a city for a period of 12 days. So we're starting on May 1st with a temperature of 77 degrees, and we see the different temperatures all the way through to May 12th with a daily high then of 82 degrees. We have the same information here, and we're going to use our horizontal axis to represent the day of the month. So we can start with 0, and then we have, going up by 2s, 2, 4, 6, 8, 10, and 12. On the vertical axis, we're going to have the temperatures, and notice that all of our temperatures are either in the 70s, the 80s, and we have a high of 90. So we're going to go ahead and start with, notice our lowest temperature is a 77, so let's go ahead and mark off that we're not starting at 0 and extending upward. I'm going to choose to start with the value of 76 and then go up by 2s, so this will be 78, 80, 82, 84, 86, 88, and then 90. These will be my temperatures. And of course, this is in degrees Fahrenheit. And now we're going to work with similar way we did the scatter plot. Let's say at May 1st we had the value of 77, so I'm going to go 177. Then we have the same temperature on the 2nd. On the 3rd we have a value of 79. On the 4th we have a value of 81. On the 5th we have a value of 82. On the 6th, the value that's also 82. On the 7th, we have a value of 85. On the 8th, a value of 87. On the 9th, a value of 90. On the 10th, a value of 88. Then we have a value of 89 on the 11th. And then on the 12th, we have a value of 82. Now, the reason this is going to be called a time series graph is at this point we're going to connect the dots in order to show what's occurring as the month goes on. So we're connecting the dots in sequence. And what we can see is that it appears it was hottest from May 7th to about May 11th. And that, therefore, we're told in a representative manner, in a graphical manner, about our daily high temps in May. And so now it's your turn to try to work with a few of these graphs on your own.